Welcome. Today we will learn examples of Cartesian curves. In last lecture, we see the rules to trace the Cartesian curve. We see the first symmetry, even powers of y, then symmetry about x-axis, even powers of x, then symmetry about y-axis. If even powers of x and y, then symmetry about both x and y-axis. These three are important. Remember. Then origin and the intersection with axis. Put x equal to 0 and y is equal to 0. We got the intersection with the axis. Tangent at origin. For this we equate the lowest degree term to 0. Tangent at any point. For this we find dy by dx at point xy. Asymptotes. For finding the asymptotes, either we put denominator equal to 0 or we equate coefficient of highest power of x and y to 0. Region of absence. For this we find such a values of x at which y square is negative. We see the example. Trace the curve x y square is equal to a square in bracket a minus x. Write down example. Now for simplification we write y square is equal to a square in bracket a minus x upon x. Check the powers of x and y. If we see the powers, power of y is 2 and power of x is on numerator 1 and on denominator is 1. Here in example even powers of y. Therefore first point, if the even powers of y, then symmetry about x-axis. Next, find origin and the intersection with axis. For this, we put y is equal to 0. If we put y equal to 0, then we got a square in bracket a minus x upon x equal to 0. Therefore, we got a minus x is equal to 0. Therefore, we got x is equal to a. Therefore, curve passes through the point a0. Here, curve does not passes through the origin. For finding the tangent, we only find the tangent at point a0 because here curve does not pass through the origin. Here, third point, tangent. Tangent at origin does not exist. We find the tangent at point a0. For finding tangent at point, we find the value of dy by dx. Now find the dy by dx. For this we consider the equation y square is equal to a square a minus x upon x. Now take derivative with respect to x. Here we take derivative of y square is 2y dy by dx is equal to derivative of the RHS side. We write derivative of RHS side. Don't find the derivative, write the term as it is. Now for simplification, we write this 2y of the LHS side right on the RHS side. Therefore, you got dy by dx is equal to 1 upon 2y into the derivative of the term. Now find the value at a0. dy by dx at a0 is equal to, here value of a is x is a and y is 0. We only put the value of y 0. Then we got 1 upon 2 into 0. Now 1 upon 0 is infinity. Therefore, we got the value of dy by dx at point a0 is equal to infinity. If we got the infinity, then tangent is parallel to the y-axis at the point a0. Okay. First point we got the symmetry about the x-axis. Next we got the point of intersection. Point of intersection is a0. Next is the tangent at the point is the parallel to y-axis. Next is asymptotes. For finding the asymptotes, we put the denominator equal to 0. If we see the example, denominator is only x. Therefore, we get vertical asymptotes, that is x is equal to 0 is the asymptotes parallel to y-axis. If the symmetry about x-axis, always asymptote is parallel to y-axis. Therefore, this x equal to 0 is the equation of y-axis. Therefore, here asymptote is the itself y-axis. Next, find the region of absence. For finding the region of absence, we consider y square is equal to a square in bracket a minus x upon x. Now find the value of x at each y square is negative. If we consider the denominator term x is negative, then we got a square in bracket a minus x. Here x is negative, therefore we got a minus x is positive upon the negative. That is, we got y square is equal to negative if x is less than 0. Therefore we consider the first value. If x is less than 0, y square negative. Now consider the value of x is greater than 0. If we put the value in the numerator, a square in bracket a minus x, if x is greater than 0, therefore we got a minus x is negative. Therefore we got negative upon positive term, that is the negative. If x is greater than a, then y square is negative. Therefore here we got x less than 0 and x greater than a is the region of absence. Therefore we consider region of presence is here if we consider x in between 0 to a in each curve exists. Therefore this is the presence of curve. Now by using all these points we trace the curve. Now for first symmetry, we draw the xy axis. Next is the point of intersection. We consider here 0 0 is the origin and a0 is the intersection point. We consider the a on x-axis is the distance, then by using this we got the point a0 is the intersection point with the axis. Now next point is the tangent. Here origin is not the point of intersection, therefore there is no tangent at the origin. Next we find the tangent at point a0. Here we find the tangent which is parallel to y-axis. Tangent is parallel to y-axis. Therefore we consider at point a0 tangent is parallel to y-axis, and if the tangent is parallel to y-axis, the curve touches at the point. Here we consider on the both side curve is touches. Now next is the asymptote. X is equal to 0 is the asymptote. X is equal to 0, that is the equation of y-axis. Here y-axis is the asymptote, therefore curve touches at the infinity. Therefore we consider on the both side curve touches to the infinity. Next, region of absence. Curve is exist only in between 0 to a. Therefore, we draw the smooth curve only in between 0 to a. Therefore, we trace the curve, smooth curve by using the tangent side curve and the asymptote side curve. Draw the smooth curve. This is the curve for the given equation.